Well, it's time for another math lesson, geometry. And today we're going to look at dividing shapes. We call these plane figures with equal parts. Lesson 126. And if you look on your work page, 251 and 252 is what you'll be completing after this lesson. Take a look at this picture. What shape do you see? 1, 2, 3, 4, 5. There are 6 of them all together in the picture. Can you tell me what shape that is? Well, it looks like it has 1, 2, 3, 4, 5, 6 sides, so it is a hexagon. Now, several hexagons have been fit together here. And if you look, they match up perfectly. There's no space in between them. We call this a tessellation. So a tessellation is a pattern of shapes that's repeated with no gaps. And that's exactly what you see here in this picture. Now I wonder what kinds of shapes can form a tessellation. Let's look at another group of shapes. What shapes are put together in this picture? If you said a square, you would be right. How many squares are there? Well, I see 1, 2, 3, 4, 5, 6, 7, 8, 9 squares, all fit together with no spaces in between. So another example of a tessellation. What shape do you see in this picture? If you said circle, you would be right. Now, is a circle a tessellation? Remember, a tessellation is a pattern of shapes that's repeated with no gaps or overlaps. So, if you look at that picture, you can see that the circles do not fit together perfectly. You have this little curved diamond sort of shape in between the different circles. So we would not call this a tessellation. How about this shape? I see several triangles. Looks like 8 of them, and they are all fit together. Are there any gaps between them? No gaps. So triangles can also form tessellations. Here's another shape. What shape do you see here? Well, I see most of the shapes have 5 sides. That would be a pentagon, but there are a couple strange shapes in the middle there. Do you see those diamonds? That means that pentagons aren't put together so that there are no gaps in between. So this would not be an example of a tessellation. And you recognize this shape, don't you? 8 sides. So it's an octagon. Yes, an octagon. Can octagons form tessellations? Well, I see a couple of squares in the middle of this group of octagons. So unfortunately, octagons cannot form tessellations. Now, look at these 2 triangles. It's interesting if you look at them carefully and you look just at the outward lines, not the lines that are touching each other, but the outside shape, and you look at that as one large shape. What shape do you see? If you said rhombus, you'd be correct. So 2 regular triangles can form a rhombus. What if we put 3 triangles together? Do you see another shape there? How about a trapezoid? Do you see the trapezoid formed by the 3 triangles? And let's check this one. When you put 4 triangles together, you get another shape. Does anyone recognize that shape? If you said parallelogram, You would be right. Now, there's something that's the same about all three of these shapes. Can anyone find what's the same? Okay, they all have how many sides? Yes, they all have 4 sides. How many vertices do they all have? That's right, they all have 4 vertices. And that means they're all special kinds of quadrilaterals. So, interesting, we can take shapes and make other shapes. Today, you're going to be looking at how you can divide shapes into pieces, equal pieces. So here is a shape, and it's 6 triangles that have been put together, and it's forming a hexagon. And if you were to incorporate our knowledge of fractions, each of those triangles is the same size. So we could say that each one of those is 1/6 of the hexagon. You can do that with other shapes as well. So in previous lessons, we talked about a hexagon having 6 sides and 6 angles, 6 vertices. We also recognize that a hexagon has 6 equal parts if it's divided properly, and each part looks like a triangle. Okay, so you're going to, again, you're going to do some work like this on your pages, dividing squares into parts, or dividing shapes into parts, not just squares, other shapes as well. And especially looking at equal parts. So have fun with this lesson. I think you're going to enjoy it. But if you get stuck, as always, give me a call and I'll be right here to help you.